Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over the role of the discriminant. Alright, we're going to start off by going over what the discriminant is. Okay, so the discriminant is a component of the quadratic formula. Okay, so let's start off by writing the quadratic formula. The quadratic formula is given by x equals negative b plus or minus the square root of b squared minus 4ac, the entire thing divided by 2a. Okay, so b squared minus 4ac over 2a. Okay, so a particular component of this quadratic formula represents the discriminant. Okay, the discriminant, which can be written as using the delta notation, is equal to b squared minus 4ac. It is simply the radical component, the radicand of the quadratic formula. That's what the discriminant is. Okay, so the power of the discriminant is that it enables us to predict the number and nature of the roots of a quadratic equation. So without solving the equation, a quadratic equation, we can predict what the roots will look like, the number, and if they're rational or not, or if they're imaginary or not. Okay, so we're going to be looking at 4 cases that we could use the discriminants to describe the nature of the roots. Okay, so let's start with case 1. In the first case is where we have a discriminant value that is less than 0. Okay, we're looking at the negative case. If you have a negative discriminant, you are going to have 2 imaginary roots that are different, okay, or distinct. The result of this is because if you have a negative discriminant, you're forced to take the square root of a negative number, which results in an imaginary result. Recall what happens when you take the square root of negative 1. The square root of negative 1 is I, an imaginary number, so the square root of any negative number will have that I component attached to it. Now let's take a look at the second case. Case 2, what if your discriminant is equal to 0? If you have a 0 discriminant, that means that you're going to have 2 real rational roots that are what? That are the same. Okay? 2 real rational roots that are the same. This is a special case known as a double root. You have 2 identical rational real roots. For case number 3, we're going to flip to the positive side now. What happens when you have a discriminant that's greater than 0 and a perfect square? If you have a discriminant that's positive and a perfect square, you're going to have 2 real rational roots that are different. 2 real rational roots that are different. Okay? If you think about rational numbers are numbers that can be written as the quotient of 2 integers, or as a repeating decimal, or a terminating decimal. That's what a rational number is. If you have the radical component attached to a number, then that number is irrational. That takes us to case 4. What if we have a discriminant value that is greater than 0 and a non-perfect square. In this case, you're going to have two real irrational roots. The irrationality results from taking the square root of a number that's not a perfect square, so that radical component will remain in the simplification. Okay? Two rational roots that are different. Okay? So these are the four cases that we're going to be using to describe the nature of the discriminant, the nature of the roots of a quadratic equation after determining what the discriminant value is. Okay, let's write down the instructions for the three examples we're going to be doing. We're to find the discriminant, delta, and describe the nature of the roots with justification. Okay? Alright, let's take a look at the first example. Let's say we have a quadratic x squared minus 4x plus 4 equals 0. What are our a, b, and c values? A is equal to 1, the coefficient of x squared. B is equal to negative 4, the coefficient of x. And c is equal to 4, the constant. Note that your quadratic must be in general form first before you start determining what your a, b, and c values are. Okay? Alright, so now that we know that, let's write down the formula for our discriminant. The discriminant is given by delta, and that's b squared minus 4ac. Okay? Now we're going to substitute. Our discriminant is going to be negative 4 squared minus 4 times a times c. Okay? Now we're going to use the order of operations. Please excuse my dear Aunt Sally to simplify this expression. Negative 4 squared is positive 16. Remember, minus times minus is positive. Minus 4 times 1 is 16. We have a discriminant value of 0. Okay? Alright, so that's our first answer. Next answer is we want to describe the nature of the roots and justify why we have that result. Okay? So in this particular case, let's write down our conclusion. There are two real rational roots that are the same. Okay, this is known as the double root scenario. And why do we have this case? Well, it is because the discriminant is equal to 0. Okay? Now let's take a look at question number 2. What if we have the quadratic x squared plus x minus 5 equals negative 4? We need to find the a, b, and c values. So what are our a, b, and c values here? If you note, this equation is not yet in standard form. Okay, so caution is place your equations in the general form. In the general form, what is the general form? Ax squared plus bx plus c equals 0 form first before finding a, b, and c. Okay, so please keep that in mind. That's extremely important. You need to make sure that your quadratic equation is in the right form first before you find a, b, and c. So to accomplish the desired form, we need to have this equation equal to 0. So we need to add 4 to both sides. And that will give us the desired form, x squared plus x minus 1 equals 0. Now let's rewrite our formula for the discriminant. The discriminant, delta, is given by b squared minus 4ac. So the discriminants, well, let's figure out what a, b, and c are first. Okay, so in this equation, we can see that a is 1, b is 1, and c is negative 1. So if we plug it into the discriminant formula, we're going to have 1 squared minus 4 times 1 times negative 1. Let's simplify that using the order of operations. 1 squared is just 1. Minus 4 times negative 1 is positive 4. 1 plus 4 is 5. Okay, so this is our discriminant value. Our discriminant, delta, is equal to 5. Okay, now, what's the nature of the roots of the quadratic equation with a discriminant value of 5? Let's go ahead and write down the conclusion. There are going to be two real irrational roots that are different, or you can say distinct, two real irrational roots that are different. Why is that? Well, since our discriminant is positive and not a perfect square. So if it's not a perfect square, the square root is going to be irrational. Okay? So this is a justification as to why we have two real irrational roots for this given quadratic equation. Alright, let's take a look at another example. Now let's say we have the quadratic equation 4y squared plus 4y plus 6 equals 3. Okay? We need to find the a, b, and c values. As you can see here, our equation is not yet in general form, so we subtract 3 from both sides to have it equal to 0. So we have 4y squared plus 4y plus 3 equals 0. Okay? So this helps us to see that a is 4, b is 4, and c is 3. Now, let's refresh our memory with the discriminant formula. The discriminant formula, delta, is given by b squared minus 4ac. Okay? So let's go ahead and substitute and simplify. Delta is going to be 4 squared minus 4ac. If we simplify, 4 squared is 16, minus 4 times 4 is 16 times 3 is 48. 16 minus 48 is negative 32. So this is our discriminant value right here. Now let's use that result to describe the nature of the roots. So in this case, there are going to be two imaginary roots. Okay, that are different. You don't have double roots in the imaginary realm. Okay, two imaginary roots that are different. Why is that the case? Since our discriminant is less than 0. So if you have a negative discriminant, you automatically have two imaginary roots that are distinct. Okay? Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of quadratic equations and the quadratic formula and the discriminant, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other algebra tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.